From the previous section, we know that we can complete the square and write a quadratic equation in the perfect square form. The method is based on the fact that if you have m plus n in parentheses squared, you can FOIL it and get m squared plus 2mn plus n squared. And the same is true for subtracting m minus n, quantity squared. This will give you m squared minus 2mn plus n squared. In general, we can determine the constant term c so that x squared plus bx plus c is a perfect square by squaring half of the coefficient. So this is like 1/2 b squared. And this should be fairly familiar because we just worked on this in a previous section. But this is our big rule to remember to find the c term. If we want to write a perfect square trinomial whose first two terms are given, we need to find c. The rule says we take 1/2 of b, where b equals 12, and then square it. This will be equivalent to 6 squared, so it will equal 36. That means that if I want a perfect square trinomial, I would have to have 36 as my third term, c. Let's take a look at example B. We need to find c such that x squared minus 5x plus blank will give me a perfect square trinomial. C, I know, can be found by taking 1/2 of b and squaring it. This is equivalent to 1/2, in this case, b equals -5. So I'll multiply by -5. This will give me -5 over 2, and then I will square it. I can rewrite this as 25/4. So my c that will make this trinomial a perfect square trinomial is 25 divided by 4. We are now going to take the methods we just tried to create perfect square trinomials, and we are going to use that rule to make x squared plus y squared plus 6x equals 11 look like a circle equation. My first step is to group the terms that have like variables. So x's need to be grouped separate from the y's. X squared plus 6x, move over a ways, give yourself plenty of space, then put the y squared equals 11. We need to figure out what number would go here as a third term on the x's, plus question mark, we don't know yet, to make this a perfect square trinomial. But remember, if I add something on this side, the left side of the equals sign, I'm also going to have to add it on the right side of the equals sign because it is now an equation, not an expression. So I'm not adding it and subtracting it from the same side anymore. I'm just keeping both sides balanced. So now let's take c equals 1/2 b squared. So I have 1/2 times 6 squared. That will give me a 3 squared. And so I know that I need to add 9 to both sides. So I will add 9 to the left side of the equals sign and also to the right side. That's keeping the equation balanced. Now, if I know that this is a perfect square trinomial, I can use the similar methods. Actually, it's the same concept as I was using in the previous section. I know that I can write this as two binomials that are identical, x and x, 3 and 3, and it'll be a plus plus. So my final equation of the circle will be x plus 3 quantity squared. That's from both binomials multiplied together. I have a plus y squared, and 11 plus 9 is 20. Now remember, this is just scratch work right here. This is scratch work to find C. So once I have that, then I can write my perfect square trinomial as two binomials multiplied together, drop down my y right here, y squared, and add my right side of the equation together. That gives me my 20. So this is a circle, and its center is at -3, 0, and its radius is at square root of 20. Now you could simplify that further. Let's go ahead and do that. We know that 20 has a 4 and a 5 inside of it. 4 times 5 is 20. So 4 is a perfect square, so I could bring that out as a 2, and my square root of 5 is left inside. 5 is not a perfect square. So my radius in beautiful notation would be 2 root 5, not some repeating decimal. Now let's look at B. Again, we're going to group the x terms separate from the y terms. So I have an x squared plus 4x, and I have a y squared minus 10y. Over on the side, I'm going to take 1/2 of 4 and square it. That will give me 2 squared, which equals 4. So I'm going to add 4 to my first trinomial. Now it's a trinomial. But if I do that, I also have to add it on the right side of my equation. So adding 4 to the right side as well. Now I'm going to complete the square on my y's. I'm going to take 1/2 of 10, -10. That's going to give me -5. And then I'm going to square -5, so I get 25. So I'm adding 25 to both sides of my equation, keeping it balanced. Now I'm going to write the final equation of the circle, but it might be helpful to see the binomials first. I have an x plus 2 times an x plus 2. I have I'm running out of room, y minus 5 times y minus 5. And then on the right side of the equation, I had a -20. Add 4, add 25. So that's a 9, if I combine all those. So now I will have x plus 2, quantity squared, plus y minus 5, quantity squared, equals 9. So my center for this circle is at -2, 5, and my radius is the square root of 9, or 3. Let's take a look at the last example we have here. So grouping all my x terms together, I'll have 3x squared plus 6x. And now I'm going to group all my y terms, so 3y squared minus y equals 0. It may have been a while since you've used fractions, so I'm just going to warn you, this is going to take a few minutes. It can be a little intense, so just, follow along as best you can. Remember, with completing the square, you have to factor out the leading coefficient if it's not 1. So I'm going to divide these by 3 and these by 3. When I do that, I'm going to have a 3 out front. I'm going to factor the 3 out front on my y as well. And it's still equal to 0. And now I need to figure out what's going to be left inside the parentheses. I'll have an x squared plus 2x. I'll have a y squared minus 1/3 y. Now I need to find my c's that will make these perfect square trinomials. For the left perfect square trinomial, this is the one that's with x's, I will have 1/2 of 2 squared. That's going to give me 1 squared, which just is 1. So I'm going to add 1. Don't forget to multiply the coefficient or the common factor to the number inside. 3 times 1 is 3. So I've in effect added 3 to the left side of my equation. So I'm going to add 3 to the right side. Now I'm going to work on the perfect square trinomial with respect to the y's. I have 1/2 times negative 1/3 squared. This will give me negative 1/6, and then square that, that will give me a 1/36. So adding 1/36 inside parentheses. This is my plus c. However, I need to remember to take the 3 out front and multiply it to the 1/36. This will give me 3 in the numerator and 36 in the denominator. That will reduce to 1/12. So I'm in effect adding 1/12. So I'm adding if I'm adding 1/12 on the left, I need to add 1/12 on the right of my equal sign. Now I think we're good to go. So we are going to now rewrite these as binomials. Have an x and an x, a +1 and a +1, the 3 out front still. On the y's, I will have a y and a y, a negative 1/6 and a negative 1/6, and on the right, I have 6 plus 1/12. If I get a common denominator here, I'll have 36/12 plus 1/12, so 37/12. And I can't forget to keep that 3 in front of my binomials. Now I'm just going to write this whole thing out so that it's a little more obvious what's going on. I'm going to take my scratch paper here and put it in boxes. This is how I got my C's, just to keep track of everything. I know it can get a little messy. So I have 3 x plus 1 quantity squared plus 3 times y minus 1/6 quantity squared equals 37/12. We are so close to being done, and hopefully you've been able to survive to this point. Remember, I can't have constants in front of my x minus h and my y minus k. So I have to divide that out. So if I divide the left side by 3, I also have to divide the right side by 3. Now you may be wondering, okay, so I have a fraction, divide it by 3 over 1. That's going to be weird. When I divide by 3, this is, in effect, I'm backing up here just for a second so you can see what's more simple. Multiplying by 1/3, multiplying by 1/3. Would you agree that that would give you the same thing as what I had just a second ago? Totally does. So multiplying by 1/3 is the same as dividing by 3. So whatever I do to the left side, I do to the right side. And my final answer, once the 3's are divided out on the left side, will be x plus 1 quantity squared plus y minus 1/6 quantity squared equals 37/36. Now I can write my center as -1, +1/6, and my radius as the square root of 37/36. And we could simplify the denominator. 37 can't be reduced or simplified in a radical, but we could write this as 37 under the square root, all divided by just plain old 6.